Hello and welcome to today's GFG problem of the day, game of XOR. Let's see what the problem has to say. Given an array A of size n, the value of an array is denoted by the bitwise XOR of all elements it contains. Find the bitwise XOR of the values of all subarrays of A. So what the problem is trying to say is, for example, the given input will be n equal to 3, array will be given as 1, 2, 3, right? For example, so they are saying is uh, uh, we need to XOR the values of all the subarrays of the array. So what will be the subarray? What will be the all subarrays of this array? 1, 1, 2, 1, 2, 3, right? 2, 2, 3, and 3. So these are all the possible subarrays of this particular array, right? Now what they're saying is we need to do XOR of all the values of the subarrays, of the values of the subarrays. XOR. Okay. Okay, so what will be XOR of 1? XOR of 1 will be 1 only. So what is XOR basically? You know the property of XOR, right? 0, XOR 0 is 0, right? 0 XOR 1 is 1, 1 XOR 0 is 1, and 1 XOR 1 is 0 again. Okay, so this is the property of XOR. So this is what will be the XOR of 1? 1 is a single element. That means it means 1 XOR 0. This means this. So when any element XOR 0 will be the element itself. Okay, so 1, 2. XOR of 1, 2. What is 1, 2? What is the binary representation of 1, 0, 0, 1? And the binary representation of 2 is 0, 0, 1, 0. So if you see the property of 1, 0, 1, 1, 0, 0. So the XOR of 1 and 2 is 3. Okay, 3. Now the XOR of 1, 2, 3. Oh, I think I missed. Yeah, nothing, no problem. The XOR of 1, 2, 3 is 0. XOR of 2 is again 2. XOR of 2, 3 is 1. Okay, and XOR of 3 is 3 itself. Okay, now once we get the XOR of the subarrays, we need to do the XOR again of the resultant values. Okay, so whatever it is, right? 1, 3, 0, 2, 1, which gives us 2 as a final output. So the expectation is this. Okay, now let's see what can be the brute force approach, right? The brute force can be O of n square. What we can do is, for example, we can run a for loop I equal to 0 to n, right? And for j equal to I to n, right? So this particular two for loops will give us all the subarrays. Now what we can do, we can have a XOR variable here, and then we can do this particular for loop. Inside for loop will give a particular subarray. Okay, so what we can do, XOR equal to whatever is the A of j, right? So this will hold the XOR of a particular subarray, and then we can have result, right? Result equal to 0, which can, what we'll do after we have the resultant XOR value of a particular subarray, we can store it. We can do XOR. We'll do XOR and store this in the resultant final result, right? And we can return result finally. Okay, after the two for loop ends, right? So, but this the time complexity for this will be O of n square, right? Which is not the expected time complexity. The expected time complexity is O of n. Okay, so what we can do, how we can solve this problem in O of n. Okay, so let's see some patterns. Okay, let's see some patterns. For example, if we have uh for example, let's say, yeah, for example, we have this array, right? 1, 2, 3. Okay, what are the possible sub arrays, right? 1, 2, 1, 2. We have seen this 1, 2, 3, right? 2, 2, 3, and 2, right? And okay, so let's calculate the frequency of the elements, right? The frequency of the elements. So if you see, what is the frequency of 1 here? 1, 2, 3. The frequency of elements across all the sub arrays, right? 3. Then what is the frequency of 2? 1, 2, 3, 4, 5, right? 1, 2, 1, 2, 3, 2, 2, 3. Oh, sorry, 3, 3. Sorry, this is 3. Okay, so this is not, this will be 4. Okay, 4. 1, 2, 3, and 4, right? And then what is the frequency of 3? 3, the frequency of 3 is 1, 2, and 3, right? 1, 2, and 3. Okay, and let's see an even length array. One, for example, 1, 2, 3, 4, right? So what are the possible sub arrays? 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, right? Then 2, we have 2, 3, 2, 3, 4, right? 2, 3, 4, right? And then we have 3, 3, 4, and then 4 finally. Okay, now if we calculate the frequency of 1, what is the frequency of 1? 1, 2, 3, 4, right? 4. Frequency of 2, 1, 2, 3, 4, 5, 6. Frequency of 2 is 6, right? And frequency of 3 is 1, 2, 3, 4, 5, 6. 6 again. And the frequency of 4 is 1, 2, 3, and 4. 4. So if you observe something, so you see whenever there is an odd length array, the size of the array is n equal to 3, right? So the alternate elements starting from 1, the first, third, fifth elements will be odd, right? Will be odd. And the the second, fourth, sixth element will be even. Okay, will be even, right? Okay, and if you see the even length array, whenever there is an even length array, 1, 2, 3, 4, right? The size of array is 4. So here the frequency is all the frequency of the elements are even, basically, are even. So when you see, right, whenever the frequency of element is even, right, we want to do XOR. Now, for example, now whenever there's an element, right, whose frequency, for example, let's say there is 2, right, the element is 2 and the frequency of 2 is 2, right? So we want to, if you do XOR, right, XOR. So what will be the XOR? 0 0 1 0 0 0 1 0. 2 XOR 2 will give us the property of XOR 1. XOR 1 is 0, it will give 0. So whenever there is an element whose frequency is even, okay, and if you do XOR with that frequency, right? XOR with that frequency, it will give us 0 only. So 1, right? 1 XOR 1 XOR 1 XOR 1, right? 4 times 1, it is going to give 0 only. Okay, so this will be 0, this will be 0, this will be 0, right? And so, and if you see, right, if you see, the first, third, fifth elements are going to be odd in case of odd length array, right? So for example, what does this mean, right? 1 XOR 1 XOR 1. So what it is going to give us? The same element 1. For example, it is 3 XOR 3 XOR 3. Okay, let's do it. 0 0 1 1, right? 0 0 1 1 0 0 1 1, 3 times, right? So if you see, oh no, I think I made some mistake. 0 0 1 0. Yeah. So this is going to give us 0 if we consider 2 times, right? 0 this. So 1 1 makes 0 XOR 0 XOR 1 gives us 1 again. 1 XOR 1 will give us 0. 0 XOR 1 will give us 1, right? So it gives us 3. It will give us the same element. Odd frequency of the XOR of odd frequency, right, of the element will give us the same element. Okay, here same element, and here it will going to give us 0. So this is a one example, right? 1 2 3 4 5, right? This is one example where I've shown that the first, third, fifth element are going to be odd, the second, fourth, sixth elements are going to be and so on, are going to be even. And the even length array, the XOR is always going to be 0. So doing this, right, we are calculating the frequency, right? We are calculating the frequency, and then we are doing XOR is similar to what we have seen here, right? What are they doing here, right? Finally, what are they doing here? They are doing XOR of sub array, right? Right? Whatever the XOR of sub array, and then finally they are doing XOR only. So it is the same thing as what we did here, right? What they're doing is basically they are doing XOR of all this 1 XOR 1 XOR 3. This is let me see. Yeah. So it is nothing but what they're doing is we can do this as well. We can say this as 1 XOR 2, right? Let's do the XOR of all the subarrays, right? Right? 2 XOR 3 XOR 1 XOR 2 XOR 3 XOR 2 XOR 3. It's the same thing what we have done here. What we are doing this way. Okay. Okay. So the solution boils down to, if it is an even length array, the XOR will be 0. If it is an odd length array, we only have to do XOR of the first, third, fifth element, right? And that too, frequency does not matter, as the 3, right? As I've already seen, as I've already shown, 3, it is going to give us 3 only, whatever is the frequency. Okay. So if you see, here is a code. The Java and C++ code is like almost same, right? If it is odd even length array, we are simply returning 0. And if it is odd length array, so what we're doing is, see, first took the first element, right, in the answer. Then the third element we are starting from. I equal to 2 0 based index, that becomes third element, right? And then here we are incrementing I with 2. So it is always going to do XOR of the odd of the elements at odd position, 1 3 5 7 9 and so on, right? So, and finally we are returning the answer. So here is a solution. Let's submit it. So yes, it is accepted. Thanks for watching. Please like the video and subscribe to my channel. It will motivate me to create videos for you. Thank you so much.